When you look up at the night sky, you see only a fraction of reality. In fact, every star, planet, and galaxy that we can detect represents only 5% of the actual universe. In the early 20th century, astronomers like Fritz Zwicky and Vera Rubin found a discrepancy in how spiral galaxies behave. This schematic compares the expected rotation curve against the actual data. Stars at the extreme edges of these galaxies were expected to slow down as they moved further from the center. Instead, they are orbiting so rapidly that the galaxies should fly apart. Since these galaxies remain intact, something unseen is acting as a massive source of gravity. Our accounting of the universe is missing an enormous, invisible component. This chart shows the composition of the universe. It is split into 5% visible matter, 27% dark matter, and 68% dark energy. Dark energy acts as a repulsive force. It is distributed uniformly throughout the universe and causes empty space to expand at an accelerating rate. Dark matter provides the attractive pull that holds galaxies together. It clumps in specific regions, accounting for 27% of the total mass and energy in the cosmos. It is defined by what it doesn't do. It does not absorb, emit, or reflect any form of light. It is invisible across the entire electromagnetic spectrum. How do you build a trap to catch a substance that makes up a quarter of our reality but cannot be seen? The primary suspect is the WIMP, the weakly interacting massive particle. These are theorized as heavy, ghost-like particles that rarely collide with normal atoms. Other candidates include axions, low-mass particles theorized to solve a flaw in nuclear physics, and primordial black holes, which may have formed in the first seconds after the Big Bang. Some researchers argue we shouldn't be looking for particles at all. Modified Newtonian dynamics, or MOND, suggests that Newton's laws of gravity change at the extremely low accelerations found at the edges of galaxies. However, MOND has difficulty explaining observations like the Bullet cluster. When these galaxy clusters collided, the visible gas, traced here in pink, slowed down, but the gravitational mass, mapped in blue, continued forward unimpeded. Because the gravity physically separated from the visible matter, scientists conclude that dark matter must be made of physical particles. Catching them requires extreme stakeouts. This search requires near total isolation from the surface. To look for WIMPs, scientists travel 1.47 kilometers into an old South Dakota gold mine. This is the Lux-Zeppelin detector. 10 tons of ultra-pure liquid xenon are heavily shielded from outside interference. If a single WIMP passes through the Earth and hits a xenon nucleus, the recoil produces a tiny flash of light and an electron stream. Because these interactions are so rare, this is the quietest, most heavily shielded environment ever built for dark matter detection. At the University of Washington, a different experiment targets the much lighter axion particle. The ADMX experiment uses a powerful 8 Tesla superconducting magnet wrapped around a resonant microwave cavity. The goal is to use this magnetic field to force an invisible axion to convert into a detectable microwave photon inside the chamber. Whether they are waiting for a collision deep underground or forcing a quantum transformation in a magnet, researchers are pushing engineering to its absolute limits to find these particles. Why go to these lengths to find something we cannot even see? In the early universe, radiation pressure scattered normal matter, but dark matter was unaffected. It was able to clump together early, forming a vast network of filaments called the cosmic web. These filaments created gravity wells that pulled in ordinary gas, providing the scaffolding necessary for the first stars and galaxies to ignite. Without this gravitational pull, the expansion of the universe would have spread normal matter too thin for structures to form. We would live in a starless, uniform soup. This cosmic web extends through the space you are in right now. Billions of dark matter particles are streaming through your room, passing through your body every second, without you feeling a thing. This invisible architecture is the most elusive part of our universe, and it is right here.